Hello and welcome to the next presentation from the Made With Defold Jam 2025. Today our guest is Eugene Mozok and he will be talking about his experience with meshes, a very powerful component in Defold.
Greetings for everyone who is on the second day of Made with Default Jam organized by Pavel. Today I'm starting this talks with topic meshes in default. My name is Eugene. I'm a developer at Refold, and I'm also working with my indie team. Let's say like that, the Deb's Brain. I will talk about mesh components in default. I will talk general about what is meshes, and I will show a lot of code examples. And in the end, I will share a link for the GitHub repository with all the code examples as a default project. So I encourage you now just to try to understand what you will understand, because it will be a lot of information. After that, recheck repository, recheck all the code, and try to play with meshes yourself. If you have never used it, mesh is a 3D component in default. One of the 3D components, we have models and meshes. It looks like on the right. And when I choose to use it, I think of it in several cases. First is when I want kind of sprite, but I want the sprite to be flexible. So I want to kind of move part of the sprites in different locations. I want to wave the sprites, or I want to create some kind of a surface with the sprite. I use mesh for that. When I have some data and I want to create geometry from this data, this could be just a one-dimensional array, and I could create a surface from this one-dimensional array, and I will show the example of this. And the last one, if I not only want to create some geometry, because for this could be used just models, but if I want to change, restructure this geometry during the runtime. For mesh component, if you create it in the editor, you need, of course, material as for anything that will be drawn. You need vertices, we'll talk about them, and you need some image to be drawn on the surface on the mesh. In general, we need to have a buffer and we need to have an image. If we create mesh from the editor, we could use just images. We can't use atlases. I will show how to, in runtime, use atlases. Buffer, set vertices, image, set texture, and the material, draw some kind of a surface. This surface consists of the points, and all these points connected creates this surface. In general, we will talk about triangle meshes. It means that all surface, like this hill, consists of the points, and they are formed in triangles. Kind of on this image, they flat squares, but in fact, it's triangles. There could be kind of different type of meshes, but we will talk about triangles. For this, we need vertices. Already that word was before. Vertices is points in space. In simple example like this, it's two-dimensional points, but in default we will have vector 3 because everything is three-dimensional. And for example, we have point 0, 1, 2, point 0, 1, 2, they form triangle T1. These points should go in order counterclockwise. And if we want to have a square, we need two triangles, T1, T2, and these two triangles have same points. P2 is the same for T1, T2, and point 1 is the same for triangle 1 and triangle 2. Also, every point, every vertex could have a normal. Normal is also vector 3, and it mainly is used for calculating lighting. If we don't have any light and we don't want light to be on our scene, or we have kind of simple light examples, we could neglect normals and just use vertices, and after that UV coordinates. I will talk about them. Buffer. If we create buffer in the editor, it will look like that. kinda JSON with several objects. In general, buffer resource is used to describe stream of values. It could be any values for any reason that you want. Mesh usually uses position values, so it's like vector 3 that describe position of the points. Like here, every point is vector 2. We will place here vector 3. Normal also vector 3 for every point, for every vertex. We will have additional normal. And text coordinate is UV coordinates, so like coordinates in the texture space. So we have atlas with a lot of images. We need to know where every image placed in atlas, because whole atlas is kind of one texture. Also, it's crucial to understand that data in these streams, in position, normal, text coordinate, data will be one-dimensional array. And we use this count value to explain the default that, okay, this is one-dimensional array, but these values are grouped by 3. It could be anything, but we, in abstract, we will think about them as x, y, z. For the buffer, they don't care. Would it be x, y, z, uv, anything? They have one-dimensional array. It's just for us, because we will have vector 3, when we need to understand that we need to convert vector 3s to one-dimensional array. Example in the editor, you could check this example from default examples. Simple triangle. Color of it is shader magic, so we could skip it. But here, what you need to look at is the points. I've kind of do a new line, so points looks like grouped by 3, but in fact everything is comma. So this is just one line of the values. Point 0 is lower left corner. Point 1 is the lower right corner. Point 2 is top middle. So this is how we draw just a simple triangle. In the editor, it would be like that. So we have a object, we have a mesh, we have a custom material. Again, it's from example from the official examples. Here is no texture because material has no texture. The vertices is the same as was on the screenshot. Next, let's do a square. For square, we need 4 points and we need 2 triangles. Again, we could create them just in the editor. It's like a text file. You could edit it as a text file. As you can see, here was minus 0.505. So the values could be anything. You could place 100, 1000. Yeah, we have 4 points, P1, P2, P3, P4. And we describe the 2 triangles. First triangle and second triangle. Also, we have text coordinates. This is coordinates of the image. If I open Square Base, here we connect just a simple PNG image. So it's just a green square image. Yeah, the same as I shown. 0, 0. It's okay, let's do like that. 0, 0 is 0.1. So here we have 0.1 and here we have 0.1, 0.2, 0.3, 0.2, 0.3. So like the same points, but this is coordinates for the texture. For the texture, UV coordinates, they are in the range from 0 to 1. 0.00 is kind of lower left corner of the image. 0.11, it's top right corner of the image. So not in pixels, but UV coordinates is from 0 to 1. I have 2 images, green and blue, and I have atlas with 2 images. As you can see, blue image is rotated inside the atlas. It's kind of crucial. Again, during the runtime, we could think about this atlas as one big image, one big texture. Like in my case, it's not big, 32 by 16 pixels, but in a real project, they will be big. Like if we want to create something in runtime, we will use fabric with prefab game object. In prefab game object, we just have just a simple mesh with empty buffer. During the runtime, we will create values and we will kind of fill stream of the values for this prefab, not kind of this prefab, not this buffer, we will create new buffer, because if you want to change amount of data, so like amount of values, you need to create new buffer. We will set it to the vertices and set texture. So kind of imagine same as I could do in the editor. So in the editor, I could choose vertices, choose my file. I could choose texture, choose my file. We will do kind of the same, but in code. We also will create buffer and we kind of set this as vertices, but with lower code. To draw just a square in runtime, we need an array of vertices and set these points. Previously was like P1, P2, P3, P4. We do the same. We describe these points as vector 3, and we know that counterclockwise points should be, we set these two triangles. So 1, 2, 3 will be first triangle, 1, 3, 4 points from the vertices array. First, third, and fourth points would be second triangle. Again, we had our buffer as a JSON. Now we need to create it in code. Line 51, we do buffer create, and we create kind of the same structure. We also create position, we create text coordinate as here, position, text coordinate. Float 32, again, here for float 32. Count 32, because here's vector 3, here is kind of vector 2, UV coordinates. What we do, we create the size, buffer with certain size. In runtime, we could use this buffer with smaller amount of values, but we can't use this buffer with a larger amount of values. So this is kind of maximum amount what we can use in runtime. If we need more, we need to create new buffer. Indices multiplies by 3, because for every index, we will have vector 3. So every index will be x, y, z in the buffer. Yeah, we create buffer and we get stream of the buffer. Buff is kind of all this file, and variable positions and text cohort 0 is kind of this line data. So if we want to change this data, we change this variable stream. For yeah, let's do with the line 5967. So like we are going through these indices and vertices. In array, we are going through the indices and just x, y, z putting separately in positions. A text coordinate for now it's just 0, 1, only for test. We need to create, we had this buffer, but we need to create buffer resource. And for it, we need a name. For the name, the main restriction for the name, it should be ended with .bufferc. The name could be anything, but it should be ended with .bufferc. So we create resource and say that buffer of this resource is our buffer. Only here we could take this buffer resource and set it to the vertices. Yeah, kind of several steps. In the editor, we could just go vertices and select buffer, and in runtime default will create all the resources. But in code, we need create buffer. That is kind of structure. From buffer, we create resource, and after that, we set this resource to our vertices for the mesh that we created with factory. Well, a lot of creations. And the next step is Atlas. So we have Go property as declared as a resource Atlas. We could check it with self game Atlas, name the same. We could get Atlas itself from the resource. Here will be resource. We could get Atlas from this resource, and we could have texture from the Atlas. So like Atlas is one texture, and we set this texture to our mesh. So 72, 73, this kind of the same as we do here, texture and select image. this would be the result. I understand that this result's like not remarkable and too much too simple, and it's just a blue square because we set here we uv 01. 01 is kind of top left corner, so like all the points in our mesh are the color of the top left corner of the atlas, and it's just a blue. Next step, we want to get like image from the atlas. If we check atlas resource, this one, if we do resource get atlas, we have variable atlas. If we during debug check what's inside we will have a texture. We already see it, so like it's kind of name of the image. You could associate it as a name of the image for our atlas. We have animations. I've created atlas just with images, so there is no animations. But in runtime, they called animations, and they called the same as the image name. So like green 8x8, blue 8x16. So we have these animations, and here we could have the green and name of the image. We have geometry with the same indices, UVs, and vertices. We have flag rotated if it's from default 111. But if you use default previous to 111, there would be no rotated flag, and I will show how you could calculate it. If we check Atlas geometry, we will have indices and UVs. We need these UVs to understand where the image inside the atlas. So like we have this green image, but we need coordinates in the atlas, coordinates of this image inside the atlas. For this, we need UVs. But as you can see, first of all, these UVs not in 1 to 0 or 0 to 1 range. It's in the range of the pixels. Our atlas is 32 by 16, so it's in the range 32 by 16. Okay, we could map it. Indices looks like 0, 1, 2, and how they are attached to these coordinates. In fact, every indices points to like these two coordinates, and first one is always u or x coordinate, second is always v or y coordinate. That's why 0 is these two values, like these values, they are from the C side, and in Lua we start arrays from 1, but on the C side we start from 0. That's why 0 is kind of first elements in the array. 1 is second, 2 is third pair, and 3 is the fourth or last pair. Ooh, okay. What we can do? We could get texture info from the atlas to understand the size of the texture, because atlas don't have information about its size. We need to get texture info to get the whole information. We could search for the name of the image to get index. Here, like green 8x8, it's first index, and we need to get first geometry. But if I haven't known like the indexes, I better search for name of the image. And let's just go in the cycle, check every index, and get these UVs, get this UV, and map them to 0 to 1 range. Result would be like that. Doesn't seem like image that we want to show. That's the issue. If we try to say that this is 4 points for our texture, 1, 2, 3, 4, and we try to draw these points on our atlas, we will have this part of the atlas. And yeah, it's not what we expected. The issue is that these coordinates in the atlas are based on the top left. So for the mesh, for UV coordinates, for material and draw and everything, we need lower left based coordinates, but these values are top left. So y kind of in inversed. Somewhere on the forum I heard it name as textile coordinates. Not sure is I'm using term right. So yeah, let's say top left based. What we could do is we could just reverse 1 minus v, and yeah, but we will get not the same image. The image will be reversed. This is because, like everything, the order of the points also kind of reversed. It could be fixed in several ways. One way that I've chosen is I just get all the points, find these points of geometry for one image. I found minimum and maximum points, and just convert them to that structure that I want. So I want the first point to be top left, so I said that this will be top left. And after that, I could draw in runtime this image. And these calculations also will help us if we do rotated images. Yeah, if we just draw them in the square, the image will be rotated because in Atlas it's rotated. So we need to check, is it rotated? In default 111, we could use just flag rotated. If we use default previous, we could check them by calculating actual white and comparing actual white in the texture with the white that is stayed in the image. So we know that white and height, this is rectangle image, white and height, what should be in the geometry. And based on it, we could create UVs array for our vertices. It's again 0.1, 0.2, 0.3, 0.4. And we could take into account is it rotated. So a lot. I was talking like almost 30 minutes, and we just have everything that you could do with one sprite. And at this point, the question is, well, why? This was all crucial to understand it. First, you could have any geometry with vector 3. You could draw this geometry. You could take any atlas with any image, map this atlas with using text coordinate to this mesh, and this could be kind of anything. We could create more points, and after we create more points, we could modify these points in runtime. So like if I go for the update function, yeah, if I go for the update function, I will have like this is my indices and vertices. I just saved them to some variable, and inside update function I could use, for example, sign function to change y coordinate and just rewrite positions that we have this stream buffer get stream positions. I could rewrite them in the update. I could rewrite part of them. I could rewrite all of them as I want. Here I want to move every frame, move every all this image, parts of the image to be moved as a wave. So I use sign to move it. I could move them arbitrary way. And I don't need to map all the image to one mesh. So I could create two mesh with different game objects, different mesh components, map parts of the image, and do just go animate and move two meshes that are represent part of the images. I could do this in 3D. With this example, I've added normals. In addition, when I create a buffer, in addition to position in text coordinate, I added normals, and I changed this variables of normal, just the arbitrary. I set the light property for the material, also for the arbitrary value. And here it's kind of waving, so it could be wave of the sea, and yeah, here is animation, but I could just make it like mountains, so I could set the position for the vertices and they will look just like a stale mountain without animation, of course. Here is the best part of the meshes, that you could twist them, you could bend them, whatever you want. For example, I was part of the team that worked on this game. We were porting project for the Pocky. You could check Skill Motocross 2 at the Pocky. This is the racing game, and in fact, I would say the most part that you see on the screen are meshes. At the beginning, we have just an one-dimensional array. So this green line in this animation, this green line is representing this one-dimensional array. This array has just height of this track of the ground. Beneath the bikers, you already see shadows. Shadows is also meshes, and you could see that these meshes are kind of repeating the curve of the track. We have one-dimensional array, we create mesh, and the texture is just image of the ground that infinitely repeats. From one-dimensional array, we have ground, like a two-dimensional, and we have perspective camera, so in fact it's even three-dimensional. Yeah, it's flat, but it's flat in like three-dimensional way. After we have this ground for the track, we add in grass on the sides of the track. We add in back grass, front grass, and in the bottom we have this skirt, just black to have a contrast. So yeah, track is mesh, grass is mesh, skirts mesh, shadow is mesh, bikers and bikes themselves are also meshes. And yeah, sprites are only background. So what you see, there are several layers of sprites. This is background, but everything else is meshes. It's much more easier to save, for example, one-dimensional array that describe track, and in runtime create all the forms for this track, and it would save you a lot of space. Check it out, Pocky Skill Motocross 2. And another example is a prototype that I'm working on now. It's Cozy Cut. You could check it at itch.io. So I have an idea what I could do if I cut the mesh. And yeah, I'm creating like this cozy game about patchwork, about colleges. It starts as I've shown before. So it starts just with the square, like 4 points, square, and one image. And every time I draw the line, I check the points where a line cross the mesh. I've created 2 new points or more based on geometry. But in general, I create 2 new points and I divide this mesh in 2 meshes. So in every cut, I take mesh, divide it to 2 meshes, and recalculate UV coordinates, so the image kind of also divided. Also, tip for you, this prototype I've created using Cloud Code agent that you could use in console. It helped me pretty much with all the mathematic points that was I kind of not very strong in, and it helped me a lot to create all the mathematics for it. Yeah, it has its own issues, but here it really helped. That would be all. So like, if you want to see what I'm doing, check it out at X, Twitter, Mozok Evgen. If you want to check this example with all the meshes, you check the GitHub link. I will post it to the Discord. And if you're interested in cozy game about cutting anything, check it out at itch.io. And that's all from my side. That's a good question, and that's the point that I want to try. I believe everything will work, but I don't have an example right now. But I definitely will try it, because yeah, I want to create inside this cuts. I want to try to create animated textures. Yeah, that's it depends. There is several ways how you could construct it. If you do like in the example, so just create buffer and get stream, and after that you all buffer create resource and set it resource to vertices. Yeah, this stream is dynamic, so you could change this position anytime, and they will dynamically change like on the side of the, let's say, engine side, on the C side. So like it's stream, it's called stream, so you could change it. But if you have not an empty buffer and you want to change data in this buffer in runtime, you could do so. So you could do like go get vertices and change the data. And I believe if you do like that, so modify buffer created from the editor, you need to reset it. So like I'm not sure, or you need to do go set every time, or other function, not quite sure. So yeah, if you create buffer by yourself from code, everything works as a stream. You just change stream and it's updated. If you use already created in the editor buffers, you need to do additional step, and every time when you update stream, update this kind of reference.